The Zweckverband Frohnbach, a sewage treatment association with headquarters in the Saxon town of Limbach-Oberfrohna, operates a central municipal sewage treatment plant in the municipality of Niederfrohna. It has a purification capacity for 40,000 population equivalents and is about 80% utilized. It produces around 1,400 tons of digested, dewatered sewage sludge per year. Its soil-related use is no longer possible due to legal changes. Instead of continuing to process it into compost and then using it in the recultivation of open-cast miners, the sewage sludge must now be incinerated as waste in a lignite-fired power plant. The ash is useless and is disposed of. This interrupts the natural cycle of materials. In addition, incineration capacities are dramatically increasing, and the cost of sewage sludge disposal is rising steadily. Statutory disposal is no longer guaranteed, and dependence on disposal companies is increasing dramatically. In order to put an end to this tiresome situation, the Sewage Treatment Association had decided to build a model and pilot plant for the decentralized thermal conversion of municipal sewage sludge of the central Niederfrohna sewage treatment plant. The innovative project was supported by European Union funding from the European Regional Development Fund. For efficient drying, it is important to remove the sewage sludge, which tends to have a sticky consistency, from the so-called glue phase. This is done particularly well in the jumbo speed rotary dryer. A paddle screw adds dry material to the moist sludge and thus increases the dry substance content to approximately 55%. In the drying chamber, the sludge is swirled in a material cloud by fast-rotating vanes at constantly 300 degrees Celsius hot exhaust air. The physical conditions are almost ideal, which leads to an unprecedented efficiency. This process requires only about 700 watts of thermal energy per hour to evaporate 1 liter of water. The sewage sludge passes through the individual drying chambers, and after only a few minutes of dwell time, it is dried to the usual target value of 85% of its dry matter. Now the dried material is fed dust-free to the pelletizing unit via a transport line, which is closed to the outside. The ZRP 250 jumbo pelletizing machine installed here was specially developed for such biomasses as sewage sludge, which have a high mineral content. In the ZRP 250, slow rotating press wheels compress the dried sludge into compact, very stable cylindrical pellets, and at the same time guarantee an exceptionally long service life of the pressing tools. The pelleting process is carried out without additives and remains largely dust-free due to the special geometry. The pellets are germ-free, abrasion-resistant, and can be stored safely. They can be handled easily and universally with any transport logistics. The entire production process is kept under vacuum and is dust-tight on the outside. In the subsequent pyrolysis process, the pellets are decomposed in an oxygen-free atmosphere at 650 degrees Celsius. The result is a black mineral granulate, The product, known as carbonisate, is free of germs, as well as organic pollutants and foreign substances, such as drug residues, plastics, synthetic polymers, etc. Moreover, it contains plenty of readily available phosphorus and black carbon. This carbonisate is an environmentally friendly substitute for phosphorus mineral fertilizers produced from imported ores and is climate-friendly, soil-improving, and humus-promoting, as in Terra Preta. The exhaust air resulting from the drying process is led through an integrated self-cleaning filter system and completely freed from dust. The exhaust air, together with the exhaust gas from the pyrolysis combustion, is led through a biofilter made of bark mulch, wood chips, and root wood. Organic odorous substances are oxidized by microorganisms so that the air, which smells of soil and compost, can be released to the outside. With the process shown, multiple sewage sludge can be efficiently processed where it is produced and returned to our natural material cycle via pyrolysis with a negative CO2 balance, free of any germs and practically without waste.